This is experiment 16 from Human Physiology with Vernier. This experiment uses the hand dynamometer sensor, which I already have connected into my LabQuest. The LabQuest is connected to the computer, and I've already got my Logger Pro software running on the computer, which automatically identified that the hand dynamometer was connected. This sensor measures grip strength, which can be an important indicator of different neuromuscular conditions. This is used a lot by orthopedic surgeons and physical therapists for evaluation of the extent of an injury and also recovery. It's also used in sports medicine a lot for lots of different things such as football, tennis, rock climbing. Almost anything where you use your hands, grip strength is going to be an important indicator of your overall progress. As with any of the Vernier sensors, this should not be used for patient diagnosis. It's intended for educational purposes and not for medical purposes. So for this particular activity, what we're going to do is go into the File menu and choose Open, and then go into the Human Physiology with Vernier folder, and then choose Experiment 16, Part A, which is the first part of this lab. And when I choose Open, it'll open up a new graph of force versus time with a shorter duration. This is only going to last for 10 seconds. The scale is already set appropriately for the type of values we expect to see in this lab. And what we're going to do is compare right hand strength versus left hand strength. So what I do is just hold the sensor upright, and then I'm going to zero it before I begin the run. So I just click the 0 button, and what that's going to do is define the current setting as 0 newtons of applied force. As soon as I do that, you'll see that the live readout goes to 0.0 newtons. And then when I'm ready to start, I click Collect. And I'm going to let it run for a couple of seconds just to get a baseline, and then I just grip the sensor for the remainder of the run. And I'm just going to squeeze as hard as I can until the 10-second run is ended. And what we're going to do to compare it to left-hand strength is we're going to store this run. So we go under the experiment menu and choose Store Latest Run, and you'll notice that the software turns the trace line from a thick line to a thin line, indicating that it's no longer the live run of data. And now I'm going to switch the sensor to my left hand and click Collect again. And I'm going to do the same thing, basically let it run for a couple of seconds to get a baseline, and then squeeze with my left hand for the remainder of the run. And right away you can see pretty dramatically that there is a difference in the hand strength between my right hand and my left hand. I happen to be right-handed, so the right hand strength is greater. We see that a lot with the dominant hand being the stronger of the two hands. So if I were left-handed, you'd see the reverse results. So we can put a little bit finer point on that by doing some analysis of the data. And what I can do is just select the region of the graph from when I was gripping the sensor, and then click the Statistics button, which is going to give me the option of doing the analysis on either just one run or both. So I'm going to select both Run 1 and my latest run. And then I'm going to get 2 floating dialog boxes that give me a statistical analysis for the data that I collected. In this case, what we're interested in is the mean value, which you can see is quite a bit higher for my right hand than it was for my left hand. In part 2 of the activity, what we're going to measure is the pincer grip strength, which can be the same type of indication of different neuromuscular strengths and weaknesses, progress from injuries, including carpal tunnel, things like that. So what we're going to do is go into the File menu and choose Open. We go into the Human Physiology with Vernier folder again, and then inside the folder we go to experiment number 16B, which is the second part of this activity. It's going to prompt me if I want to save, and normally you'd either have the students save the data or write it down for comparison purposes. In this case, we're just going to not save it. Now that I have my new graph open, you'll notice that the x-axis is set to go for 20 seconds, and that the y-axis only goes up to 150 newtons because we know that we're going to have lower total applied force than we did when we were using the whole hand. So I'm going to hold the sensor vertically again, and I press the 0 button. That's going to define that current setting as 0 newtons of applied force. And then once I click Collect, I'm going to get a real-time graph of force versus time again. So first I'm going to grip with my pinky for a couple of seconds, and then I'm going to go to the next finger, and the next, and lastly with my index finger. And you can see right away that again we've got a pronounced difference between the different fingers. To do the same statistical analysis, what we do is just select the region where the force was applied, and then select the statistics button from the toolbar. And I'm going to do that for each of the regions so that I can compare the mean values and see how much of a difference there really is between those different fingers. And you can see right away that you do have greater strength in the fingers that are closer to the thumb. They both tend to be more muscular, and you've got better leverage between the thumb and those fingers. When we do this activity with students, we compare lots of different variables, including age, height, weight, gender, hand dominance, and frequency of physical fitness. One of the popular ways to modify this activity, because you have the Word files and you can easily make that change from any of the labs, is actually to make it into a competition, because anytime you can make it into a competition, particularly with teenage students, they'll always be more engaged.